Good morning, class. Today we're going to start going over the review for the final exam. So we will start with number 1. Function g is defined by g of x is equal to a over x plus 8 over x squared. Then it says if g of negative 1 equals 0, find a. Right, so g of negative 1 equals 0 is what we really need here. That tells me that when I plug negative 1 in for x, my whole function g of x is equal to 0. So 0 is equal to a over negative 1 plus 8 over negative 1 squared. So a divided by negative 1 is just negative a. 8 over negative 1 squared, which is 1, is just 8. We can add a to both sides, and a is equal to 8. Pretty straightforward there. Right, number 2 says to find the domain of each function. And 2a, our function is x minus 2 over x squared minus 4x minus 5. All right, well, there's only two things that really can restrict our domain at this point. That is zeros in the denominator and negatives under square roots. So those are the two things that we want to look for in each function. Right, this function obviously doesn't have any square roots, but it does have a denominator. Right, so really all we have to do is say, okay, well, whatever in the denominator cannot equal 0. Right, so we're just going to factor this, and this is x minus 5, x plus 1. All right, whenever we have two things set equal to, or in this case not equal to 0, we can do each one. So x minus 5 cannot be 0, and x plus 1 cannot be 0. So x is not allowed to be 5, and x is not allowed to be negative 1. All right, now remember, this is going to be a multiple choice test, so your answers will probably be in interval notation. So we would say from negative infinity to negative 1, not including negative 1, union negative 1 to 5, not including 5, union 5 to infinity, not including 5 again. All right. 2b, our function f of x is equal to the square root of 3 minus 5x. Right, well, we can't have zeros under square roots. We do have a square root here. Well, how can we guarantee that this is not negative? Well, we take what's under the square root, and we say, okay, well, that has to be greater than or equal to 0. If you're greater than or equal to 0, you cannot be negative. All right, so from here, we just solve like normal. So negative 5x greater than or equal to negative 3. Divide both sides by negative 5. Do be careful. Remember, with inequalities, when you divide, multiply, or divide by a negative, you have to flip that inequality symbol. So x is less than or equal to 3/5. So in interval notation, that would be from negative infinity to 3/5, including 3/5. And that's it. All right, 2c, we have f of x is equal to the absolute value of x minus 4. All right, well, there's no square roots. There's no denominators to be 0, so there's nothing here that's going to restrict our domain. So our domain is going to be all real numbers, negative infinity to infinity. To D, function is x squared minus 2x plus 7. Again, here there's no square roots, there's no denominators to be 0, so my domain is all real numbers, negative infinity to infinity. All right, number 3 says to use the graph of f to find. All right, and I'll do just a kind of a rough sketch of the graph here. I won't really be super specific, but it looks something like this. That's obviously a little off, but you should all have it in front of you and understand what that looks like. So it says A, find the domain. And these do stop right here. There's not an explicit like point there at the end. All right, but since there's no arrow, we can assume that it just stops right there. All right, so my domain over here, this is negative 4, and this is positive 4. So the domain would be from negative 4 to 4 inclusive. All right, B, the range. All right, well, down here we have negative 2. Up here we have positive 1. So my range is from negative 2 to 1, also inclusive. All right, C asks for the local maxima and local minima. All right, so this and this will be my max. This down here is my min. Remember, endpoints are not maxes or mins. Right? So maxes, right, over here, we're going to have negative 1, 1. And you can just write it as a point. All right, here is 1, 1. And then the min is at the origin right here. So 0, 0. All right, D. It wants to know whether the graph is symmetric with respect to the x-axis, the y-axis, or the origin. Okay, so x-axis, of course, would mean that the x-axis is acting as a mirror. No, it is not. Y-axis means that the y-axis is acting as a mirror. Yes, it is. All right, so this is symmetric about the y-axis. All right, just for clarification and explanation. All right, to be symmetric about the origin for any point x comma y on your graph, the point negative x comma negative y has to be on the graph also. So for instance, if the point 1, 1 is on my graph, which it is, if this were symmetric about the origin, it would have to have the point negative 1, negative 1, which it clearly does not. Okay. But for every single point that's on this graph, if you took the exact opposite of both coordinates, it would also have to be on the graph. That's what it means to be symmetric about the origin. All right, E, it wants to know whether the function is even, odd, or neither. All right, a function is even if it's symmetric about the y-axis, which it is. So this is an even function. It's odd if it's symmetric about the origin, which we just kind of discussed. And if it's not symmetric about the origin or the y-axis, then it is neither. All right. And just as a side note as well, if you're symmetric about the x-axis, you're not even going to be a function. Okay, so You obviously can't be even, odd, or neither if you're not even a function to begin with. And finally, f wants the intercepts. All right, well, here this is -2. Here this is +2. And of course, we have the origin here. So we would have -2. I guess we should be a little bit more specific since x-intercepts would be -2, 0, and 2, and the y-intercept would be 0. Right? Since it's the origin, it's both. And that is it for number 3. Okay, number 4 asks us to graph the function, and then it gives us a piecewise function. I'm going to go ahead and skip over this, primarily because you're taking a multiple choice final, which means you're not going to be doing any full out graphing by hand. So if you're not going to do it on the final, I'm not really going to take the time to do it on this review. However, I may ask you to evaluate a piecewise function, but that is very, very simple, right? So if I said, what is f of 3, you would just find which one to plug it in. Well, 3 is not less than -2, so you wouldn't plug it into the top. 3 is not equal to -2, so it wouldn't be the constant 3. Right? 3, however, is greater than -2, so you would plug it into that bottom piece, and you get -3 plus 1, which equals -2. Right? So that's very straightforward and simple, but I'm not going to take the time to graph 4. Number 5. Right? Find the average rate of change. And that just stands for rate of change there. All right, from 2 to x for f of x equal to 2x squared plus 7. Okay, now average rate of change, all that means is slope. All right, and our formula for slope is y2 minus y1 over x2 minus x1. Okay, so this is going to be my x1. This is going to be my x2. Right, and then of course to get my y's, I plug it into my function. So y1, which is going to be f of 2, is equal to 2 times 2 squared plus 7, which is going to be 15. Right? 2 squared is 4, times 2 is 8, 8 plus 7 is 15. All right, y2 is going to equal f of x2, which is just f of x, which is just my actual whole function, right? When you plug x in for x, nothing changes. Okay, so now plugging that in over here. All right, so we're going to get 2x plus 7 minus my y1, which is 15, over x2, which is x, minus x1, which is 2. All right. So now this is going to be 2x minus 8 over x minus 2. All right, you can factor 2 out here if you want, but it's not really going to do anything. All right, but you kind of sometimes want to, just to make sure nothing's going to cancel. But nothing cancels, right? So whichever one of these two you saw as a multiple choice answer, probably this one, would be what you would select. All right, number 6 says to graph each function using transformations. All right, of course, again, we're not going to be graphing on a multiple choice test, so I'm not going to spend a great deal of time graphing all of these functions. Of course, they're easily graphed, like it says in the directions, using transformations. You just take the parent function and apply the appropriate transformations. That being said, instead of graphing them on a multiple choice test, I may very well ask you what the transformations are, right? So part A says the absolute value of x plus 3 all minus 5, right? So as far as transformation is concerned, this plus 3 inside would take me to the left 3, and this minus 5 outside would take me down 5. Right? Part B says f of x is equal to 2 times the square root of x minus 3. So the square root function is our parent function. This minus 3 inside would shift me to the right 3. And this 2 multiplying outside would be a vertical stretch by 2. All right, C, we have f of x is equal to negative 2 times the quantity x minus 5 squared, all minus 3. All right, and remember, technically, you kind of want to keep these, the order in which you apply transformations is the order in which you would do things according to order of operations. So first we would do things inside the parentheses, right? So this is going to go to the right 5. Then we would multiply by negative 2. Well, this is kind of two different transformations, and the order in which wouldn't matter because multiplication is commutative. All right, so this will be a vertical stretch by 2, and that negative is a reflection, since it's outside, about the x-axis. And then finally, the last thing we would do, order of operations, is this minus 3 at the end. So this would go down 3. All right, D, we have f of x is equal to x plus 1 quantity cubed minus 6. All right, well, the plus 1 in here would go left 1, and the minus 6 outside would go down 6. And finally, E, f of x is equal to the greatest integer function of 2x. That's our step function. Because that's a 2 on the inside, that's actually going to be a horizontal shrink. Right? And you can say by 2, by 1/2. You're really cutting it in half. But if you say shrink by 2, that's fine because you're shrinking it by 2. That's the same thing. It's taking half. So I would accept either. Of course, multiple choice, it won't matter. Just pick whichever one's there. Okay. So again, number 6, you wouldn't be graphing those, but multiple choice, it would be very easy for me to ask about transformations. All right, looking at number 7, it says, given f of x is equal to x squared minus 3, and g of x is equal to, g of x is x squared minus 3, sorry. Son of a biscuit. Alright, f of x is 2x plus 1, and g of x is x squared minus 3. Alright, it says find the following and state the domain. Alright, so A is f plus g. Well, all we do is add these. And I'm just going to kind of automatically put them in proper order, standard form. So x squared plus 2x minus 2. All right, the domain here, there's no square roots or denominators to mess us up. So my domain is all real numbers, negative infinity to infinity. All right, B, f minus g. All right, so f minus g, we do have to be a little bit careful here that you kind of put this whole thing in parentheses because we have to distribute that negative to both. We're not just, a lot of people just subtract the x squared and then still subtract 3, but if you're subtracting a negative 3, you're really adding. All right, so again, we'll have negative x squared plus 2x, and then 1 plus 3 is 4. Again, there's no square roots or denominators to mess with us here, so my domain is all real numbers. All right, C says f times g. So here we're just multiplying. And we're distributing. So here we're going to have 2x cubed and then plus x squared, then minus 6x, and then minus 3. And I intentionally multiply them in such a way that it's already in standard form. If you didn't, that's fine. Just make sure that you put it in standard form. Again, there's no square roots or denominators to mess with us here. So my domain is negative infinity to infinity. There were no like terms to combine here. Of course, if you have like terms, make sure that you combine them. And finally, D is f divided by g. All right, so that's going to be 2x plus 1 over x squared minus 3. Okay, this can't be simplified at all, so all we have to worry about is the domain. All right, well, we know that this cannot equal 0, so x squared minus 3 cannot equal 0. Since there's no b term, I don't have to factor here. I can just use square roots, right? So x squared is equal to 3, so x is equal to plus or minus the square root of 3. To remember, when you take the square root, you need the plus or minus. All right, so my domain would be negative infinity to negative square root of 3 union negative square root of 3 to square root of 3 union square root of 3 to infinity. And we are done. All right, 8. Given that f of x is equal to 2x plus 1 over 3x minus 2, and g of x is equal to 2 over x minus 5, find f of g of x and g of f of x and state the domain of each. Okay, so first we'll do f of g of x. Right, and these are going to get a little messy because we're putting fractions inside of fractions, okay? So first I have to take this whole g of x and plug it into both of these x's. So I'm going to get 2 times 2 over x minus 5 plus 1 over 3 times 2 over x minus 5 minus 2. All right, so when I multiply here, I'm going to get 6 over x minus 5. Now I would still have my plus 1, okay, but I'm going to want a common denominator. So 1 is just going to be x minus 5 over x minus 5. All All right, down here, oh, I'm sorry, this should have been 4. The bottom one is 6. All right, so the bottom we will have 6 over x minus 5. And then we are subtracting, well, 2 is just double x minus 5, so that's x minus 10. I'm sorry, 2x minus 10 over x minus 5. All right, so now we have common denominators here. All right, so up top, 4 plus x minus 5 is x minus 1 over x minus 5. And then down here, we're going to have negative 2x, and then 6 minus negative 10 is plus 16 over x minus 5. Of course, now, since our denominators are the same, we can cancel. All right, and this is just going to be x minus 1 over negative 2x plus 16. Of course, you could factor out a negative 2 here, but nothing's going to cancel. Okay, so that is my f of g of x. All right, well, now for the domain. First of all, we know that this cannot equal 0. Well, what makes this 0 is 8. So we know that x cannot equal 8. Of course, you could have just set it equal to 0 and solved, but that's easily enough done kind of in your head. Right? But then what we also have to be careful about is the inside function, right? Which is this 2 over x minus 5. Whatever is not in this domain also has to be included, and that's what most people forget. So x cannot equal 5 either. So our domain here would actually be negative infinity to 5, union 5 to 8, union 8 to infinity, obviously not including 5 and 8 anywhere. All right. So do be careful that you always have to tack in whatever the inside piece is. Okay. All right. So that's f of g of x. Now I will do g of f of x. All right. So now I'm taking the f of x, the entire f of x function, and plugging it in for x into the g of x function. When I do that, I will get 2 over, instead of x, I will have 2x plus 1 over 3x minus 2. All right, and then all of that minus 5. Okay, so 2 over 2x plus 1 over 3x minus 2. I need to get a common denominator here, so just multiply 3x minus 2 by 5. We're going to get 15, son of a biscuit, 15x minus 10 over 3x minus 2. Okay, well now these have common denominators, so I can combine that. 2x minus 15x is negative 13x, and 1 minus negative 10 is positive 11. All right, well, when we're dividing by a fraction, we can keep the top and change this division to a multiplication and flip the bottom. So 3x minus 2 over negative 13x plus 11. And when we do that, we will get 6x minus 4 over negative 13x plus 11. So we're good here. Some people may factor out a negative and put it out front and call this 13x minus 11. Doesn't really matter. But this is our g of f of x. So my domain, of course, whatever makes the bottom 0 cannot be in the domain. So set that equal to 0. Subtract 11. Divide by negative 13. So x cannot equal 11 over 13. Then, of course, we have to check the original inside function, which is this 2x plus 1 over 3x minus 2. Whatever makes this denominator 0, we're not allowed to have either. All right, so set that equal to 0, add 2, divide by 3. All right, 2/3 is not allowed either. All right, so in interval notation, this would be negative infinity to 2/3, I think. Which one of those is larger? That's a good question. I'm going to guess 11 over 13. Yes. All right, so negative 8 to 2/3 union 2/3 to 11/13 union 11/13 to infinity. And that's it. Let's see, number 9. Find the vertex, axis of symmetry, and x and y intercepts, if any, of y is equal to 3x squared plus 4x minus 1. All right, so the vertex, well, first we really actually have to find the axis of symmetry, because that actually helps us find the vertex. And that is x is equal to negative b over 2 times a, which in this case, negative our b is 4 over 2 times a is 3. Right, so my axis of symmetry, x is equal to negative 4/6, which reduces to negative 2/3. Right, now the vertex, right, we know the vertex, the x-coordinate, is just the same as the axis of symmetry. And then the y-coordinate we get by plugging that into here. All right, so really, you can just use a calculator to do this. It's much easier that way. So I'm going to use a calculator real quick to do that. That would be negative 17/3. All right, it says, and the x and y intercepts. Y-intercept is super easy, right? We just plug in 0 for x, so that's 0, negative 1. X-intercepts, if we can factor, that's the best. So we'll see if we can factor over here. I'll do my trash can method. A times c is negative 3, b is 4. All right, so are there any numbers that multiply together to give me negative 3 but add together to give me 4? Let's see. Nope. That is because it would just be negative 1 and 3, which would add to 2, or negative 3 and 1, which would add to negative 2. All right, so this is not factorable, which means we're going to have to use the quadratic formula. All right, so x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. All right, so negative 4 plus or minus, this is 16 plus 12 is 28 over 6, all right, which is negative 4 plus or minus, this is divisible by 4, so that's 2 square roots of 7 all over 6, all right, and since all of these are divisible by 2, we can reduce this to negative 2 plus or minus 7 all over 3. Right? And that's sufficient for your x-intercepts. Of course, if in a multiple choice test, if they're all decimals, that's fine. Just plug that into your calculator and get the decimal. All right, we will go ahead and stop there for now. I will pick up here a little bit later and release another video very soon.